right, hello. So I'm going to talk about touch and you are trapped. The C and K are silent. So it's about how the way we use our touchscreen devices could be used for tracking. So it's a joint work with Rahat, Ben, who are not here, myself, and Dali. So I'll begin with a typical scary stat slide. So I think for this audience, it's not a new news that mobile apps collect a lot of information. Some of it is related to the device we use. Some of it is related to more personal information, like, for instance, location. This is from a study from Zscaler, which is an information security company. It basically shows that many of the apps from iOS and Android leak personal information. By leakage here, I mean that when these apps send information to the server, these are sent in the clear text. So some of this information is meta information, like the device ID. Some of it is location information. Some of it's even more personal, like email addresses, and also contact information. So these details could be used to track users. So it could be used for, so tracking could be done using the device configuration, could be done with how you have personally set up your phone, and could also be done through user behavior. So, which is the focus of the talk today. So in particular, I'm going to talk about touch tracking. So what is touch tracking? We define it as tracking a user continuously and in the background without the knowledge of the user, while the user uses its phone or other device in a normal way. And we consider it as a new privacy threat, and particularly dangerous because it could actually identify the actual physical user behind the device. So if the same user is using multiple devices, it could be used to track that user, which is slightly different from, say, browser-based tracking, where in fact you're tracking the browser used by in a particular device. So not all of the use cases of touch tracking are bad, so it could also be beneficial for the user. So for instance, if you want to enable parental control on the device, or if you want to get the products that are of more interest to you, you could be using touch tracking to enable that as well. So this way of tracking is particularly dangerous in our opinion because of the fact that it's not that difficult to do. So it requires no specialized hardware. So many of today's devices come with, obviously, the touchscreen touchpad, and also a host of other sensors which could be used easily to track users. Now, one particular thing here is that the apps do not require any special permissions to use the fine-grained information from these sensors. And this is what could be exploited by these apps to actually track users, as I mentioned, across multiple devices or multiple users on the same device. So the goal of our work was to actually show that touch tracking is feasible. And so there are two parts. One is that we wanted to show that these touch gestures, by that I mean swipes or taps, or any other gestures we use on devices with a touch screen, are highly unique. And here it's a little bit different from tracking through other mechanisms, for instance, browser fingerprinting, because a browser profile, if it's unique, is enough to track users because it remains static over different sessions. But user behavior is inherently stochastic, so there will be small variations. So just showing that the gestures are unique is not enough. We also wanted to show that it could be used to re-identify users if the user come back in a different session. So we wanted to be able to show the feasibility by actually quantifying the information contained in these gestures. So the second part of the talk, I'll talk about this quantification methodology. So as I mentioned before, there are several scenarios of touch tracking. So single device, single user, single device, multiple user, and cross-device tracking. But our work is currently focused on the first two things. The last one is left as future work. So here's a sort of flow diagram of how we achieve this. So we first have this quantitative methodology of quantifying information contained in gestures. We then developed this special purpose app called Touch Track to collect data from users, which runs this touch analytics service in the background using the quantification methodology. We then collect data from users, we evaluate the quantity of information contained in these gestures, and finally we display these results to the users. So in more detail, so we first have this Touch Track Android app, and we focus on 4 different kinds of gestures: swipes, taps, handwriting, and also keystrokes. And then we collect features, which we do a comprehensive list of features that are available in the literature. And then from those features, we narrow down highly identifying features. We then plug them into this quantification framework, which gives us uniqueness results. So a little more about this quantification framework. So we actually assess the uniqueness of gestures at multiple levels. At the lowest level, we want to find out if a single feature extracted from a gesture could be highly unique or identify a user. For instance, one user might have a particular tendency to exert more pressure on the touchscreen. Then we go to a next level where we would like to find out the uniqueness of a particular sample of a gesture. So one complete swipe, which means all the features contained in that swipe. Then we go to the next level where we have multiple gestures, multiple samples from the same gesture, which means, for instance, multiple swipes. And at the highest level, we have multiple samples from multiple gestures. So at all levels, we would like to quantify the information contained in these gestures. So for quantification, we use this information theoretic measure called relative mutual information. So in the denominator, we have the entropy of the whole user set, and every single gesture that we obtain would reduce the amount of information required to pinpoint the actual user, which is denoted by the conditional entropy. So this measure is between 0 and 1, and the reason why we use a relative measure instead of an exact measure is because through our user study, we had different number of users for different gesture types, and we wanted to have one scale for all of them. So this conditional entropy is actually calculated from the empirical probabilities from our data set. So for the single feature, we find out the proportion of times a target user is likely to exhibit a particular feature value. For sample, which means one feature vector from one gesture, we find out the proportion of times the target user exhibits a similar feature vector. So here we can't have an exact similarity because of the number of dimensions of the feature vector. You wouldn't have an exact match. So we insert user similarity based predicate here. Likewise, for samples from multiple samples from the same gesture, we find the number of times the target user would exhibit a similar average vector. So in this case, we would combine the feature vectors from multiple gestures and take the average and compare against the user's data that's already stored. And likewise, for multiple gestures, we will find the proportion of times the user will exhibit the similar average feature vector across multiple gestures. So now is the last part of the talk, which is about the Touch Track app, experiments and results. So we built this Touch Track app with 4 different games, one for each gesture. And some of these games are available in the Android Google Play Store. We had to customize them for our purposes. So the second snapshot here is the game Lexica, which asks the user to find words by tapping on different letters in that grid. So that is obviously to check, to grab this tapping information. The next one is 2048, and this is for swipes. So with these different apps, when the user uses them, we can then display the result of uniqueness. So this one here shows the uniqueness of swipes, taps, and also at the end we have a more detailed information, detailed results for that user to see how unique their gestures are. So we actually uploaded this app on Google Play Store and were able to collect data from about 89 users and more than 40,000 samples. As you can see, the samples are not uniform across multiple gesture types, and that's probably because of which games were more entertaining and which games were not that entertaining. After we obtained this data, we went to feature extraction. So what we did for that, we divided the data set into a training set and a test set. And so we wanted to select features that satisfy 2 criteria or balance 2 things. One is the relative mutual information, which I mentioned before, which is to show how unique individual gestures are. And the other thing is true positive. So we would also want to correctly identify returning users. So true positive here means if we have a test sample and the only user that is returned by our framework is the actual target user, that's considered as a true positive. So we selected all those features which satisfied or which gave the best balance between these 2 criteria. And obviously if we increase the number of features, the relative mutual information increases, but also the true positive rate decreases. So we needed to have that balance. So on to the results. So for single features, we found out that the area, or in other words, the size-related features were the most highly identifying ones. And these are related mostly to the swipes. So the way we swipe, the area covered by our swipes is quite highly identified across users. For for single samples from gestures, we again, for single sample from gesture, we see that handwriting and swipes leak the most amount of information compared to taps and also keystrokes. And for multiple samples, the result is quite similar. We have handwriting and swipes leaking the most amount of information. Combining all the types of gesture together, we see that if we combine, if the tracking service is combining information collected from all different types of gestures, then it can reveal about 99% of information. And the most revealing combination was swipes, handwriting, and keystrokes. So as I mentioned before, the previous results are more around the uniqueness. So we also wanted to find out, if we could re-identify users. So we did this experiment, and then we found out that the combination of swipes plus handwriting is the best combination in terms of both the uniqueness of information and also the true positive rate, which relates to correctly identifying returning users, and also has the least false positive rate. Before I end my talk, just a slight discussion around, if some of you are familiar with the field of continuous authentication, so there might be some similarities in your mind. So there are some differences here, or some stark differences. The first one is the obvious aim. The aim of authentication is to verify a claimed identity, whereas in tracking you are trying to track users. So in an authentication system, you would have an input sample, and you know which target model to test against, whereas in tracking you may or may not know the actual identity of the user, and you still want to be able to re-identify users. Similarly, high authentication needs to be highly accurate, which means high TPR and FPR, and low FPR are critical. In case of tracking, that is not that a critical thing. So to conclusion, we have demonstrated that touch-based tracking is feasible by showing that it has could be used to track, re-identify users, and also these gestures contain a highly unique information. We have left this cross-device touch tracking as future work because we would need to find out those features that could actually be consistent across multiple devices. Thank you.
Questions?
Is this working? Yeah, thanks. Really interesting talk. Questions. You said approximately 89 users. I'm not sure what approximately means when it's 89. But how confident are you that this expands to more than 89? That seems like an awfully small number to be giving the number of digits of precision that you display on some of the later slides. And the other question is, could you review your threat model for me? I sort of am having trouble understanding why, if someone has the ability to install this software, to identify you. Thank you.
For the first question, so we did this with 89 users, but obviously as more user comes in, we get more refined information. But the main point here was that because users' gestures are unique, we would see a similar trend. We would probably require more samples if we get more users to correctly re-identify the target user. For the second question, so I think a best example here would be if you're using a browser application on your mobile phone, and that application, so whatever websites you try to use on your through that browser, that will be able to know if it's a returning user or not. So you're able to track multiple, you're able to track users across multiple sessions. If you have a particular app, it could also be used as an additional factor to track the user. So if you, so you could think of as adding more information that could be used to track users, with say some other information that is available already to track users. Does that answer the question? One question.
Maybe I missed this, but could you talk a little bit about what the feature space looks like and how you made those selections?
For each of these gestures, say taps or swipes, we collected the different features that were identified in related studies on, say, continuous authentication. And we had a comprehensive list of them. Then we ran them through this algorithm called minimum relevance, maximum relevance, minimum redundancy, which basically weeds out all features that are somewhat correlated with other features. And so we take the one that is maximally identifying, and then any other features that are basically giving you very similar information are not selected. So we go through this process.
Okay, so we're running a bit out of time, so just maybe one very short question.
No, it's just how do you correlate, for example, devices? Because when I'm using on my smartphone, I'm using like one-handed. For example, on my iPad, I may use two hands. Or how does the among devices work? Because the gestures may change, or the way I interact with the device may change.
Yeah, so those would be like interesting use cases to study. What we wanted to do was to see how, if you use in a typical way, would be used to track use. But those like different use cases are interesting to look into. We didn't look into those.